Hello everyone, I'm here to talk about anonymous and named functions, and this is my third video. In previous videos I talked about arity, types, values, sets, relations, mathematical functions, and functions in programming. So let me talk a bit about named functions. So I have here the definition of four functions, these two have arity 1, these three here have arity, no, this one has arity 2, and this here has arity 3. And the name of this function is f of x equals 2 times x, g of y equals 3 minus y, h of x and y equals 2 times x plus 3 times y, and j of x, y, and z equals f of x times j of y times h of x and z. So you see that the names of the functions were useful here because I could use them, f, g, and h, here to define j. So, but it's traditional in computer science and mathematics to use the lambda notation, where, for instance, see that this function here, f of x equals 2 times x, I can present it this way, lambda x 2 times x. This expresses the same function as this one, but now it is anonymous, it has no name. So for g, I would have lambda y 3 minus y, and for h, I would have lambda x, lambda y 2 times x plus 3 times y. So this is not exactly the same thing, because here I have h with 2 arguments, and here what we have actually is lambda y 2 times x 3 times y. This is a function and this is another function. So I will have to talk about currying in another video, but my point here is that I can define functions without giving them a name. And if I do that, of course, in this example, for the last function, I have to do this. I have to use the expressions here, because I cannot use the name that I gave, like f, j, g, and h, to define the last function. So that's it for today. In the next video, I will show recursive functions.